Recording live from Twitch, and we're back. And let's continue on finishing up our integration test with our socket. We had this issue with reading a negative off of read byte. We probably should change this to read unsigned byte until we can figure out what the how to get it to send a signed byte over from Elixir. So I'm going to change this a little bit. So we're going to change this over to read unsigned byte. So here we go. We're going to go to our test, and I think we have read byte someplace. Read byte. So read unsigned byte. Read unsigned byte, and we'll run that test. Make sure our integration tests are off, and we'll change this over. So that error is out, which is fine because we got an exception that says it's not implemented. So where's our read unsigned byte? So we're going to grab this, and we're going to put that on, where is it at? Read byte. So I'm going to drop that here, and then we're going to grab this one, put this on read unsigned byte. That'll get that to pass. And we'll come back and fix the signed byte. We're just going to kind of go on with this. And then we're going to turn on our integration tests, read unsigned, read unsigned byte from socket. We'll get rid of this. Read unsigned byte. And read unsigned byte. And I think we can go up to 255 on this. So we're going to run our integration test. So we're going to run here, and then run that. That's all ready to go. And actually, one thing we need to do is we need to change this to take that out. And we're going to do 255. And it goes, yeah, it goes there. Okay, so, whoop. Alright, so, running our integration tests, they should still pass with this. Okay, so it did not pass. So because we needed to have this to be 3. So that failed off the bat. And then, here we go. Let's run this again. And then we're going to go on to run our test. Yeah, that passed, that passed. Okay, so we're going to run our test for reading integers. So we'll put this down here. So let's actually do read short. And I think, let's check over on our convert int. We have unsigned short. So we don't have signed short. So we're going to have kind of the same weirdness. So let's unsigned short. And we're going to send it a pretty big number. And then we're going to do just a double check. I'm going to say byte x values. See if there's no, that's not what we want. Let's see, like let's see short x value. Just want to be double sure. So 65,535. And we got to make sure we have to do 0, so we'll have that. And we don't need this anymore. And actually, okay, that should be fine. Okay, so we're going to grab this test. Should read unsigned short, unsigned short, and this is going to be actually 6. It should be 2 bytes per unsigned short, and make sure we actually have this implemented. Okay. And now I'm going to make sure that it'll clean up there, and then we now have 9 tests and unsigned short. Okay, that should do it. And then in the meantime, so that one failed hard. Run test 3. Oh, unimed sort. Let's run it again. So that one seemed to run, but it's stuck. First off, I got this wrong. 5421 and 500. Oh no, this is still 6. 5421. 65,535. What we're going to do is we're going to just print this out. Oops, that's the wrong button. Print that out just to see what's going on with that. In fact, we should probably make sure that this is wrapped in parentheses. And see how many bytes it's actually sending. Alright, great. We got something going on. Oh, I spelled inspect wrong. So it's giving us this number. And that's actually 4 bytes. And we should only be getting 2. So I wonder if we need to just drop 4. And this one should actually be 2 bytes as well. Okay. So that looks closer. So 5 failed to error, so okay, so the value was not equal. So let's figure out why. It was on which one? It was the second one. So that's good because we had that one traced out. So let's figure out why this is. So we're going to use that value converter. And it's, oops, convert unsigned short, convert unsigned short. And actually, we've got it backward. No, I think this will work. So we'll do this. Make sure I just make it easy. Oh, we've got it backward. Can't convert that way. So we're going to do Erlang. Actually, I think we got something similar. Bin to value. Bin to value. Just get value. The game server. Game server util. There we go. So it is sending the bytes it's thinking it's sending, so the problem's not on that side. So let's take a look here. Read uint 16. That looks promising. So let's print out the value here. It's a race. All right. Okay. Betting it's right there. So let's, and that's going to be the next one, 255, 255. And this is not having it. 2145. Okay, so I'm just curious if we can test it out here. So what we're going to do is we're going to create var bytes allowed 2 bytes. Is our set 0, and then that's going to be 21. All right, and then position 1 is going to be 45. And then our buffer, new bytes buffer. Is that what we want? Add bytes. Oops. And so here. What was our input that we used? Bytes input. Is that what we used? No, we used bytes buffer. Bytes input. And that constructor takes bytes. Bytes buffer. Read unsigned, read uint 16. We're going to trace that. So we're just going to see exactly what it's printing out here. So we're looking for this one. So it is a strange number. So those don't seem to equate. I wonder if it's Indianness. Check to see what sort of So it is Indianness. And so that's a bummer. Because I think everything else worked, which is weird, shouldn't be. And I wonder if it's because of the way we're reading it off the socket backward. It might be here. Let's see here. So looks like this is sending 2145. And this is sending in the right order, same order. So they are both on the same Indian. And we traced it here. Trace. I wonder if we could just use blit anyways. So we'll try this. We'll try buffer input. Is blit available on buffer output? Doesn't look like it. Input. Let's go back here. It's only on bytes. So we do have our buffer, which is bytes. And then, so here. Here's our buffer. And so we're going to need to read the bytes off of, this is length ready. This is our read buffer. So yeah, we have it. We can put this. Okay, so buffer blit position will be position offset. And then source bytes would be read buffer. So I want to make sure our buffer was allocated. So buffer is not correct. So we need to do, oh yeah, we do have it. Okay, so our read buffer and then our source position will be 0. And then our length will be length ready. And I think we could just do that. So let's run our regular tests, our unit tests. See if that passes. And that does. It's okay. So that's going to be slightly better. This is 45 and 21. I don't think this is correct. So let's run this in the wrong state, but I feel like it's being passed in the right order, but I'm just going to verify it here. And we sort of sped things up anyway, so let's see here. Yeah, so it's still this strange number. I feel like it's the Indianness. But all right, big Indian is true. Let's take a look at the meh socket and see if we need to set this to the same thing. So meh socket, just do Indian, and there's nothing there, is there? Let's do gen TCP. Indian. Nothing Indian is there as well. So I feel like we do this in reverse. Reverse. Let's see what that does. Oops. Basically forces the Indianness. And that passes. Which seems a little strange to me. Because it's not the same thing out. But if we don't reverse it, set this back, and we set the Indianness to false. So it's using little Indian. We get other types of failures. It's actually the same failure. So it seems strange to me. I guess we'll stick with it for now. Until I get a better understanding of why it's doing that. Alright, so we'll just stick with that, and we'll find a better way to do this tomorrow, and hopefully we'll add, or maybe this is the way to do it. We're just going to clean up this code and put it into a library and go from there. Alright, I'll see you guys tomorrow, and we'll get this cleaned up. See you then.